Hi, I am Ayan Kumar Bania from SketchX Lab of University of Surrey. I'll be presenting our work MetaHTR, towards writer adaptive handwritten text recognition. Handwritten text recognition aims to transcribe handwritten text to its digital content, which however is inherently difficult, as writer-specific handwritten text are diverse across individual handwritten styles, where each style can be unique. While some might prefer an idiosyncratic style of writing certain characters, others may choose a cursive style with uneven line spacing. Traditional HTR models are trained in a single flow on handwritten text images without adaptation, and the trained model is used for recognition during inference. Although these models utilize techniques like a large amount of training data, or training on synthetic data, domain adaptation, or generalization methods to capture these style variations, they generalize poorly on unseen text images, as it is impossible to capture all unique style variations during training. We therefore propose a meta-learning-based writer-adaptive handwritten text recognition system, where the model learns to learn, or adapts to new writing styles with only a few samples during inference. Handwritten styles are not only diverse across writers, but there are a few key characters per writer that show relatively larger style discrepancies, which in turn are crucial for adaptation. Therefore, we introduce the problem of writer-adaptive handwritten text recognition, where the model adapts to new writing styles with only very few samples. We introduce a meta-learning framework to tackle this new problem, where instance-wise weights are made learnable for a character-specific loss, specifically designed for HTR. During inference, our MetaHTR framework exploits additional handwritten images of a specific writer through a support set, and gives rise to a writer-adapted model via a single gradient step update. Then, the writer-adaptive model is used to perform handwritten text recognition for texts from that specific writer. For character-specific loss, we calculate the gradient of Tth character-specific cross-entropy loss, with respect to the final classification layer, and then concatenate it with gradients of mean loss. The concatenated matrix is passed through a multi-layer perception network G-gamma predicting a scalar weight value for Tth character-specific loss. Thus, the instance-weighted inner loop loss is the weighted sum over all character loss. Our MetaHTR framework involves a bi-level optimization process. The inner loop optimization computes learnable character instance-weighted loss upon the support set, followed by obtaining a pseudo-updated model, theta-. This includes a learnable character instance-specific weight prediction module, G-gamma, and learnable layer-wise learning rate parameters, alpha. We expect theta- to generalize well on remaining validation set, thus finally updating the metaparameters by outer loop loss over the validation set. We evaluate our model on IAM and RIMES HTR dataset, utilizing 3 HTR models ASTER, SAR, and SCATTER, with word recognition accuracy for both with and without lexicon evaluation metric. Due to absence of prior work on writer-adaptive handwritten text recognition, we designed several strong baselines from perspectives of domain adaptation, domain generalization, generation, learning augmentation, and meta-learning based adaptation. Figure shows results of evaluation. While the performance gain on IAM is around 7%, in RIMES it is around 5%. Along with the baselines, we also compare our model with meta-learning based methods like typical MAML, first-order MAML, MetaSGD, and UNIL. Out of all the approaches from different perspectives, our MetaHTR performs the best for all 3 HTR models. Additionally, the more consistent character-aligned attention map after adaptation justifies our approach visually. Our model performs best with an optimal adaptation set size of 10 to 15 samples, and just one inner loop update. Varying accuracy against different character sets shows varying levels of discrepancy against MetaHTR's initialization parameter. Furthermore, characters with low accuracy mostly get higher weights, and vice versa, during inner loop adaptation process. Thank you.